Welcome to this Armada podcast produced in association with Systematic, with your host Tom Withington at the controls. Secure and responsive command and control is an ever-present need on the battlefield. C2 modernization and sophistication is likely to deepen in the future. Disparate hardware and software standards must coexist and interoperate. Meanwhile, current and future C2 systems must handle ever-increasing quantities of data. To make sense of these challenges, we're joined by Christoph Pauls, Business Product Manager at Systematic, and he joins us today from Cologne. Christoph, a very warm welcome to the podcast.
Hello, Tom, and thanks for having me on the show.
Let's begin by talking about some of the challenges around command and control on the battlefield. For example, how can legacy, contemporary, and future C2 systems all work together?
So I guess when talking about challenges on the modern battlefield, I think it's not only limited to the modern battlefield because communications has always been challenging. And only to mention a few things, we are facing things like limited bandwidth, we are facing interrupted connectivity, latency issue just due to, technology being used, security issues and all of that. So when we talk about the modern battlefield, it's not like it's new problems, but it's just additional problems or challenges that we are facing. What we do see is that communications itself is becoming more and more important, of course, going along with increased digitization on the battlefield. When we take a look at the modern battlefield, the communications itself is not limited to using specific military equipment or specific military communications anymore, but we do see modern technology, also driven from industry getting used on the battlefield. And now we suddenly are facing the challenge of living in both worlds, meaning we have to be able to communicate both in the old world with limited bandwidth, interrupted connectivity and all the issues I mentioned earlier, but as well be able to utilize all the new technology that's out there.
So with that in mind, how do we manage our electromagnetic discretion and avoid an over-reliance on digitization?
Well, that is a really good question because, of course, that reliance on communications is, again, nothing new. It's just the means of communicating. And you could say, of course, communications has always been there. And whether it's digital or whether you're using visual means to communicate, whether you're using voice, radio, well, the moment you enter the electromagnetic spectrum, you are, of course, vulnerable to, EW being detectable, being jammable, and all these things. Avoiding these things is something that you can do in several ways. And, only parts of that can be solved technically, whereas other parts have to be solved organizationally. So we're talking, one thing is discipline. So not becoming chatty, to call it that, is probably a good way to avoid relying too much on the communications. On the other hand, you, of course, want to transfer the important information. So if we come to the technology, what the technology can do for you is that it makes sure that you communicate all the important information when you have, let's call it airtime available. Whereas if you want to keep quiet, it's capable of providing you with the functionality that you require in your C2 system with the latest data you have available.
So let's talk a little bit about how the technology is changing the Signalers toolkit.
When we look back a decade or more, military used to be a major driver behind technological advancements, which then made their way into civilian use and got adopted by industry. This has changed over the past years quite heavily, with advancements in technology being made in the industry primarily and then being adopted in the military. So suddenly we are facing a situation where technology needs to be adopted by the military with all the additional requirements that the military has on security and all of that. What we've seen in, recent scenarios as well is that beyond adopting civilian technology, it becomes clear that the actual use of not only technology, but of providers of that technology from industry has become more prominent. And a very good example which probably everyone is aware of, is the use of Starlink for communications in Ukraine. When talking about that, the technology in the Signatar's toolbox that is now available comes with challenges like how do you protect your data? Because where before military equipment, let's take Type 1 radios, used to be the sole provider of encrypted communications, the military now relies on third-party equipment providing access to the actual communication platform. So let's stay with the Starlink example. Other than a Type 1 radio, it basically provides you with a transparent communication layer over the internet. No different to what you would use at home if you have your cabled internet connection or whichever you may use. Therefore, the communication access provided by the software in this case needs to make sure that classified data is encrypted before being handed over through the transmission media. As a software company, we of course also have to be aware of these developments and, well, instead of just being reactive, which causes a lot of delay, and going back to what I mentioned earlier of industry driving technology, we have to try to be proactive, like looking into what will be the next trends and how do we incorporate these. To this end, just to give you one example, I'm going to stick with the encryption example. We already a couple of releases ago saw that this is a big challenge and thought about how can we help our end users fulfilling their needs, like be able to communicate on the modern battlefield while still fulfilling their needs for security. And in that sense, we introduced the way not only to use software-based encryption of data over the network, but also to integrate national encryption solutions into the software to also fulfill specific needs in that area.
Now, Christoph, we've been talking about data there, and that handily brings me to my next question about how do we handle these increasing data rates given the limited comms bandwidth that we continue to face and we're likely to face in the future?
If we're talking about limited comms bandwidth, what we very often actually observe is that what people perceive as limited bandwidth is actually far beyond what is actually available in military communications. And what we see is that with all that limited bandwidth and the ever increasing amount of data, it becomes more and more important to focus on what is really important to transfer over the network, over what only needs to be available at another place at a later point in time. And I don't know whether you're aware of the different levels of exploitation that are being defined in the whole context of ISR. And if we talk about these levels of exploitation, it goes from level 1 exploitation, which is really the exploitation at the tactical edge, and then goes all the way over to level 3 exploitation, which is at strategic level. And of course, the things that you need to transfer over the network are really the ones that need immediate exploitation. Whereas other things, you could actually focus more on transmitting the important information, whereas keeping the additional data on site and transferring that at a later point in time. So when we talk about communications, it's a mix of what needs to go over the air against what can be transported in an offline way, like a USB disk or a hard drive or whatever there may be available at a later point in time. And the challenge for the software in here is to make sense of the different ways of communications and also to be able to see, okay, which information that I transferred online relates to which information that I transported in a different way. And that's something where software can really help you make sense of all the data that you have available and want to deliver to someone else.
There's been a lot of discussion in recent years, certainly in the military C2 circles and in the use of software at the more general level throughout defence, regarding the roles of civilian and unclassified technology in assisting some of the tasks we've been talking about. What are your views on that?
The civilian technology being able to provide a lot of good capabilities is something which cannot and should not be ignored, obviously. So whatever is available should be usable by the military as well. What is important here is, as you said earlier, avoiding the reliance on it. Whatever we do, we always need to be aware of not only focusing on one solution, but basically being able to utilize, you could say, the entire toolbox that's out there. With all this new technology available, one thing I mentioned earlier is being able to take over tasks in the software that were previously done by the communication solution. Encryption being the example I mentioned earlier. On the other hand, we may not need to worry about routing of information as much anymore because some of those communication solutions now suddenly do that for us. So it's a thin line to walk and to balance which technologies support which capabilities and where do we utilize which. Another thing to mention here is the whole concept of pace, being able to use different means of communication at the same time by defining which are your primary, your alternate, your contingency or your emergency means of communication, and at the same time what are your requirements on information to be transferred in these scenarios.
To conclude, let's talk about some of the future pressures. For example, will we see an increased demand for sensor outputs and the distribution of capabilities across the battle space?
So that will definitely be the case, with a lot of sensor equipment being available and also being available in a widespread manner. And there we're not only talking about classical sensor equipment like, let's take SIGINT equipment or EW equipment. We're actually talking about a lot of sensors like, let's take drones, right? So if we talk about small scale commercial drones, those are essentially sensors providing usually imagery information or imagery data that needs to be handled. When we take a look at that, it becomes more and more important to make sure that not every sensor data that is collected on the network is just blindly transferred over an always challenged network with regards to bandwidth, latency, priorities, and all of that. In computer science, there's this classical dilemma of the killer application versus the field of dreams. And that is, you could say, applicable here as well. So we do see that we have more and more bandwidth available and, the curve will go up. But at some point, when all the sensors are now available as well, what we see is that they will overload the network again. So it's kind of a race of one against the other. So at every point in time when integrating sensors, we need to be aware of that. And the answer to that, or one answer to that, you could say, is actually bringing the tools required to work with the data down to the tactical edge. So instead of trying to transfer all that over the network, what about bringing the computing down there? Like, talk about AI. So everybody's talking about artificial intelligence. And with more advanced sensor equipment available, we also have more advanced computing equipment available, which can help the users handle all that data. So we are talking about big data processing here. It can help the end user process the data before he actually just starts challenging the network with all that data. There's also quite interesting things that can be done on the network itself. So when we transfer data, there's really interesting approaches here on how we actually do that. And one thing, again, using AI, one approach that is being looked into right now is how can we transfer visual information in a better way? And I'm going to give you an example. So if you take a look at an image, what the human brain does, and basically it doesn't store like pixels and colors, right? That's not how our brain works. Our brain works in a manner that it says, okay, I see a tree in front of a lake and there's some waves on the lake and maybe the tree is bending to the left. So there's probably some wind from the right and all of that. And with AI technology, you can actually use the same mechanisms now to, let's say, instead of transferring that picture that you just took over the internet, take the important information from the picture, transfer that over a network, and then on the other end, use AI to draw that same image again. And it's quite interesting. So it's at a very early stage, but if you take a look at that, it's very, very interesting how accurate pictures on the receiving end actually are just based on a description of the content of the picture. And these are all things which can really help you in the future addressing all the challenges of additional sensor data on the battlefield.
Now, one of the key lessons learned from the ongoing conflict in Ukraine has been the importance of mobility, particularly for land maneuver forces. And I'm wondering what your thoughts are regarding how we accommodate that challenge of increased mobility in the C2 context.
So the challenge of mobility is probably one of those where the communication solution and the C2 solution that you are using can help you the most with. You could say when we talk about increasing sensor data, when we talk about additional data on the network, when we talk about all of that, that's something where, technology can help you, but only to a limited degree because, physics is just physics. When we talk about mobility, that is capabilities that the C2 solution, including the communications platform, can actually provide to the end user. So let's just take a command post. Instead of having a command post with all its infrastructure set up on site, a command post can just as well be operated in a distributed manner, and the communication solution that is running in the C2 component, so for SIT-aware, that would be what we call SIT-aware tactical communication, is then responsible of making sure that the important information is synchronized between the different nodes which make up the command post. So let's say the different vehicles, different installations, whatever it may be, and that the end user can work with and on the information that they have always been working on without ever noticing that they are not working in the same location. So we're talking about things like, why do I need to sit next to a person to work with him? I mean, technology can help you with that. So if you just get that mindset in place that you don't need to be co-located to work together, then the technology which is providing you with the capabilities can make sure that you have all the information and data that you need to work in this manner.
So final question for you, Christoph, is how do we stay ahead of the curve regarding electronic warfare threats?
Staying ahead of the curve with regards to electronic warfare threats is something which is going to be a constant race, because on the other hand, you could say, well, what do you think in an EW podcast is going to be the question? Somebody's going to ask the question. So how do we stay ahead of the game, with our EW capabilities? So it's a constant race. But I mean, the answer to that is basically, first of all, of course, staying alert to new technologies being available, utilizing new technologies wherever possible without forgetting the old ones. Again, if you say, how do we stay ahead of the curve? Well, you could say that some of the threats that we currently see, especially within EW, are actually threats we had probably decades ago as well. Jamming or being listened in on and things like that. That's nothing new on the battlefield. It's just something that's re-emerging. So I think it's important to both learn from the past as well as look into the future with regards to upcoming technologies, upcoming trends, and possibilities or capabilities that are on the horizon. Let's take another example in that area. For example, cloud. I am convinced that this is a very important part or puzzle piece in the entire system that you need to deploy. But like you said earlier, you should always avoid becoming reliant on this one technology. So everything we look into needs to have a backup plan, and the backup plan probably needs another backup plan. So the answer to your question is basically make use of the entire spectrum of technology instead of only relying on one. And of course, don't close your eyes to new technologies. And by staying ahead of that, well, somebody's going to win the race. It's either EW or comms. And depending on who you ask, well, everybody's convinced they will win. But I guess in this case, it's just a matter of stay alert, be open, and just try to take all the opportunities in that arise.
Christoph, thank you very much for helping us comprehend these important issues and also for joining us today on the podcast.
Thank you. And I also want to thank your listeners and wish everybody a good day.
Thanks again. And if you'd like to learn more about Systematic's products and services and solutions, please do head over to their website at systematic.com/defense. That's the English spelling of defense rather than the US spelling. That's all we have time for, and thank you very much for listening.